All right, so here we are integrating x squared times cosine x dx. Now, why do I think integration by parts here? Because I see the product of two things, x squared times cosine x. I'm automatically jumping to integration by parts. Now, you can either go off of what I told you on suggestions on how to pick u versus how to pick dv, or you can use that mnemonic, which is kind of cool, the LIATE. Okay, this is how to pick u. Now, what happens if you pick the wrong one to be u, right? What happens if you pick the wrong one to be u? The only thing that's going to happen is you're going to use integration by parts formula, and you're going to get something more complicated than what you started with, and you're not going to know what to do, right? So that the only thing it's going to do by picking the wrong u is take you longer to solve the problem. Okay, so picking the correct u helps you get through the problem quicker. So that's really what this is for, to just help you get through the problem quicker, right? You need to know this formula for integration by parts, all right? So let's see if we can do this, since we do have a product going on here. If we use the LIATE, okay, so I have an algebraic expression, A, but I also have a trigonometric expression, T. So what comes first? Well, the A comes first, so I'm going to use u equal to x squared. Okay, so u equal to x squared. So what does u equal to x squared get me? Well, du, okay, I need to know what a du is, right? And so that is 2x dx, okay? And then, so that's my u. Now my dv is what's left. It's cosine x dx. So dv is equal to cosine x dx. All right, so my dv here is cosine x dx. I need to know what v is, right? And then once I got that, then I can fill out the rest of this formula. So how do I get v? Well, I integrate cosine x dx. What is the integral of cosine x dx? Well, the integral of cosine is, I hope, sine. So the integral of cosine is sine x. So this is sine x. Now, I'm going to replace this. What do I replace it with? This is equal to u times v. So what is u? U is x squared times v. What is v? V is sine of x. Okay. Minus integral v. V is still sine of x. And what is du? Du is equal to what? It's equal to 2x dx, right? Okay, so now what do I have? Let's sum it up. So I've got integral x squared cosine x dx equals x squared sine x minus, now I'm going to take this 2 here and pull it out front, so I have a minus 2 out front. And then what do I have? Well, I've got an algebraic x multiplied by sine x dx. Can I just integrate this thing easily? I don't have a rule for product of algebraic times a sine right off the bat. So I'm going to need to use another integration by parts here. So I need to go through the list again. So LIATE, I just think late and add an I in there. That's how I think about it. Kind of cool. So if I look here, looks like I have an algebraic, and then this is a trig and a trig. So I'm going to use this as my u. So u equals, what? I've been using blue, so I'm going to stick with that. So u equals x. Now, what would happen if I had not chosen u to be x here, but instead I chose sine x to be u? Well, guess what would happen? Look, I literally flipped it around, didn't I, right? if I did that accident there, guess what it would end up doing? It would end up getting me right back to where I started, okay? So you don't want to do that. So if you stick with picking your algebraic as your u, pick your algebraic as your u again for the next iteration of integration by parts. So u equals to x, and so if u equals x, then du equals dx. And then if I use u for x, then what's left is dv. So this is sine x dx. And so what does that tell me? That tells me that v is the integral of sine, which the integral of sine is negative cosine x. So let's do this iteration again. So this is equal to x squared sine x minus 2, and then all of this is getting replaced with my formula. Remember, this is u dv, right? The integral of u dv equals uv minus v du. Okay, voodoo, right? So what is this going to be in parentheses here? Okay, this is going to be uv, so uv, so that's x times negative cosine x minus v du, which is just dx. Okay, so now I want to simplify this a little bit. So simplify before you start trying to integrate. So this is a negative and that's a negative, so that makes a positive 2x cosine x. And then, oh my goodness, that's a negative, and then a negative. 3 negatives make a negative 2 integral cosine x dx. See why it's important to simplify before you start trying to do anything else? If you don't simplify first, you're going to probably end up missing the problem by a negative or something. Okay, so be careful with that. Now, the only thing left I had to do is integrate the cosine of x dx. That's pretty easy. That's sine of x. So my answer is x squared sine x plus 2x cosine x minus 2 sine x dx. I'm sorry, plus c. Okay? So this is the integral of x squared cosine x dx. Okay, so that you can kind of see it in all of its totality here. All right, so that's 2 times going through integration by parts here. All right, so let's try one with a natural log in it. So I have an example here. Integral x cubed times ln x dx. Okay, so it's a product. I'm thinking product rule. The reverse of a product rule for integration is integration by parts. So I'm integrating this by parts of a product here, and I need to pick a u and I need to pick a dv. Okay, so how do I pick a u? I can use the trick, the LIATE. If I use the trick, the LIATE, L is for logarithm. That's what I see right here. I see a logarithm. A, this is for algebraic expression. So I'm going to pick the logarithm to be my u because that's the first letter in the mnemonic. So ln x is my u. So if ln x is the u, then what's left, x cubed dx, is going to be my dv. X cubed dx is the dv. So what is the derivative of u? That's du, which is 1 over x dx. And what is the integral of dv? That's v, which is x to the 4th over 4. Okay, if I add 1 to 3, I get 4. If I divide by 4, I get that right there. So now, remember the formula is integral uv minus v du, right? So what is this equal to? Well, u u is ln x, and v is 1 over, or x to the 4th over 4. So this is going to be equal to x to the 4th over 4 ln x. I like to write my ln, my logarithms, after my algebraic expressions. Okay, I know I swapped those around for you. And then minus the integral of v. Well, what is v? That's x to the 4th over 4 du. Where's du coming from? Well, that's x, 1 over x dx. Okay, so now what I need to do is I need to simplify this. Okay, so if I simplify inside my expression here, well, I have a constant 1/4. I'm going to pull that constant out. So I've got that negative 1/4 on the outside. Now, if I have x to the 4th over x, that's 4x's up top, 1 in the denominator. So that gives me x cubed here, dx. Okay? And so now all I have to do is integrate x cubed. And so if I integrate x cubed, I get x to the 4th over 4 plus c. Simplify here, x to the 4th over 4 ln x minus 1 over 16 x to the 4th plus c. And there's my answer right there. Okay, so that one, not as bad. Okay, only one iteration of integration by parts. If it didn't get to something simple that you knew how to use some integration rule to integrate, then you might have to use integration by parts again, right? You just use it until you don't have to use it anymore. Okay, so let's try one instead of a logarithm. Maybe let's do it with like an exponential. Okay, see what that does. X squared e to the 2x dx. Okay, so whenever I think about integrating a function that's a product, okay, I keep stressing this product here, integration by parts is what my brain automatically jumps to. Okay, there's not some u substitution that gets rid of this ugly little piece where I can just simply integrate and go from here. All right, so what I would do here is I would think, okay, I want to pick a u that's easy to take the derivative of and a dv that's easy to integrate. Well, to me, e to the 2x is pretty easy to take the derivative of. It's pretty easy to integrate, right? So it's just the application of the chain rule. But what I know about algebraic expressions, whenever I take the derivative of x squared, it breaks down. Okay, so du is going to be 2x dx, right? And if I take the derivative of that again, I get 2. And if I take the derivative of that again, I get 0. So I'm going to choose that for my u here. Okay, so just because it's easy to break down. If you go to the LIATE mnemonic, well, what do I know? I have an algebraic, which is A, and I have an exponential, which is the last letter E. So if that's the case, then I'm going to pick my u to be the x squared. Okay, it's the one that comes first. All right, so the mnemonic comes to the same conclusion that we did. All right, so this is dv is e to the 2x dx. So if you're having trouble, remember the integral of e to the u du is e to the u, right? The derivative of e to the u is e to the u. Integral e to the u is e to the u. But this is 2u, right? So that's 2u, but we got ourselves a little situation, right? Instead of it being just a regular plain Jane exponent, we've got that 2 in there, and that creates that 1/2 factor going on here. Okay, so we got to take care of that chain rule situation. So if you need to see that, I guess I can show you this one time, just going back to Cal 1 stuff. integral e to the 2x dx. If I was going to integrate this, I'd do a u substitution, 2x. And so this would be du equals 2dx. Okay. So then I would replace 2x with u. And then that takes care of this piece here. But then we also have this dx. Well, dx, to get dx by itself, I got to divide both sides by 2. So that's where this 1/2 du comes into play. And then the integral here is e to the u. So that's where that comes in. And then what does u equal? Well, u is equal to 2x. Okay? So that gives me 1/2 e to the 2x. Now you should be getting to the point where you've done this enough times where you can look and say, okay, if I'm going to take the derivative of e to the 2x, that gets me 2 e to the 2x. And if I'm going to integrate e to the 2x, well, what's the opposite of multiplying by 2? Multiplying by that reciprocal of 2, which is 1/2. So if I integrate, it gets me here. If I take the derivative, it gets me here. Okay, so you should be able to get to the point where you can just do that little part in your head. Okay? So we've got that going on there. Let's make our substitution. So remember, it's equal to uv minus integral v du. So uv is this first part here, so that's x squared times 1/2 e to the 2x minus v du. That's 1/2 e to the 2x. And then du is 2x dx. The good thing is this 1/2 and that 2 there are going to cancel, so that makes life a little bit better for us. Okay, so what do we have? We've got 1/2 x squared e to the 2x, and then minus integral of x e to the 2x dx. Okay. Now, once again, we run into the scenario where we've got the answer here, but this one is not so easily found by just doing a rule. So we have to use product here, integration by parts again. And if I use the mnemonic, I pick the algebra comes before exponential, LIATE. Okay. So whenever I do this, I'm going to have u equals x, du equals dx, and then dv equals e to the 2x dx, then v is going to be 1/2 e to the 2x right there. Okay? So substitute in, so I have 1/2 x squared e to the 2x minus, and now everything that goes in here, uv, which is x times 1/2 e to the 2x minus integral v, which is e to the 2x, du, which is just dx. Close it off. I'm gonna simplify this. So this is x squared over 2 e to the 2x, and then negative distributes in, so that's minus x over 2 e to the 2x, and then negative and a negative make a plus 1/2 integral e to the 2x dx. Now this is great because we can do this one. We just did it a second ago. We integrated this here already. We already did the work, and we found that it was 1/2 e to the 2x. So my final answer, x squared over 2 e to the 2x minus x over 2 e to the 2x plus, well, this is what? That's 1/2 times 1/2 e to the 2x, right? So 1/2 and 1/2 make 1/4 e to the 2x plus c. Okay? All right. That could be a little intimidating for us, right? A little bit intimidating for us. In the next video, I'm going to show you how to knock through this problem really quickly with the table method, Okay, so don't fret. Okay, so this is the long way to get it done, right? Using integration by parts each step here, this technique. And I'm going to show you in just a second how to use the table method, so stay tuned.